Hello, everyone. So today we're going to go over a little intro with projectile motion, worksheet number 2. So again, just making sure we identify our X and our Y. Remember, anytime I'm talking about X, um, that is our horizontal direction. Anytime I'm talking about Y is our vertical direction, up and down. Whereas X is typically how far away, like forward, back, left, right. Whereas vertical would be just straight up and down. So we're going to go over number 1 today on worksheet number 2. I have the 2 equations that you guys will need to use right up here at the top of the form. And there will be a video that appears in the form. It's just that I'm recording this and it's not ready yet. The equation on the left, this is what we use first to solve for the time. We take the square root of everything underneath, which is 2 times dy, which would be the height above the ground, divided by the acceleration of gravity, g. Please keep in mind, for g, please use g is 10 meter per second for all calculations, as I'm making the numbers be a little bit nicer that way. Please be advised that if you are asking Google uses a different value, so you will not get the same answer as them. It will be off by a little bit. The biggest challenge is with projectile motion is making sure you identify the distances correctly. One is the horizontal distance, also known as the range. Again, that is a vocabulary word that you should be familiar with within this unit. Y, that is our vertical distance, also known as a height above the ground. So as I read question number 1, the biggest thing is, again, identifying your dx and your dy, which then you're going to use to plug into the 2 equations that are on the form. So Charlotte throws one of her dolls off the top bunk of her bunk bed. The bunk bed is 2.3 meters high. If I'm talking about something being high, like that would be up and down. That is my y distance. So this is 2.3 meters. The doll travels 3.4 meters away from the bed. Away from you is a good way to know that they're talking about X, your range, how far away that you are. And then dy, 2.3, dx, 3.4. The first one, how long did it take to land? Solving for the time. Time is equal to the square root of 2 times dy. Sorry about my handwriting. The screen moves. Divided by g. When I plug in my numbers, 2 times dy, 2.3, divided by g, which is 10. And then this is what I need to type in a calculator. So I pull up my calculator. I'm going to use the Google calculator. I'm going to press square root. Oops, I already had square root pressed on another one. Square root 2 times my height of 2.3 divided by 10. Close my parenthesis, equals. And the form says to round to 2 places, 2 decimal places. So 2 places past the decimal. That's 1, that's 2, 0.67. Look the digit to the right. If it is larger than 5, round up. If it is smaller than 5, leave it alone. Since this is 8, and 8 is bigger than 5, I'm going to round this to 0.68. Usually if there is a time that is less than 1 second, I recommend using just 2 digits on that. No units in the form. I want to type in for 1A, 0.68. And that is my answer for the first half of number 1, 0.68. If you put the 0 in front or you don't, both of those answers are in there, but I am looking for 2 digits past. The next one, Charlotte throws one of her dolls off the bunk bed. How fast does it need to be moving? The time that it is falling is also the same time that it is moving forward. But while it's moving forward, to solve the velocity. Velocity is dx divided by t. Well, dx is 3.4. naught to 2.3. So I'm taking 3.4 meters. I'm dividing by 0.68. I say it was 3.4. Yep. 3.4 divided by 0.68. Oh, 5. And it did say round the answer to the nearest tenth if necessary. So over here in the form, I can either enter 5 or 5.0. Please don't put that whole thing in there. Either one, 5.0, since it says one place past the decimal. That's all. If you just have 5, again, that'll be the same. But go ahead and work on the remaining 3 problems and submit when you're done. Good luck.